Hello friends, welcome back to our channel Let's Learn and Grow Together. In the last lecture, we have seen the philosophy outline and the syllabus which is to be covered under this course. So, from this lecture, we are going to start with the first unit of this course, that is simple stresses and strains. Now, in this lecture, we are going to cover 3 points, that is definition of strength, classification of materials, and concept of stress and strains. So let us start with the definition of strength. So strength of a particular material is defined as ability of a material to resist its failure and behavior under the action of external load. So what is strength? It is the ability of material to resist its failure and behavior under the action of external load. So what is the effect of this external load on the behavior of material? What is the effect of this external load on the behavior of the material? Material undergoes a deformation. In the last lecture we have seen the meaning of deformation. Deformation is nothing but change in size and shape of the material. So the effect of external loading on the behavior of the material is material undergoes a deformation. So depending upon what is the effect of the external loading on the material, materials are classified as first one is elastic material, second one is plastic material, and third one is rigid materials. So the effect of external load on a general material is the material undergoes a deformation. Now we have to see the effect of external load on elastic materials, plastic materials, and rigid materials one by one. So first of all, elastic materials. So when an elastic material is subjected to an external loading, material undergoes a deformation. But when this external loading is removed, the deformation disappears. That is nothing but body will regain its original dimensions. So in case of plastic material, when the plastic materials are subjected to an external loading, the material undergoes a deformation. But on the removal of an external loading, deformation does not disappear. That means there is a permanent deformation. In the material. That means body will not regain its original dimensions. And in case of rigid materials, when a rigid material is subjected to an external load, the rigid material does not undergo any deformation. That is, no deformation when subjected to an external loading. So in practice, there is no absolutely elastic nor plastic nor a rigid materials. Generally, structural members are handled in the elastic range. That is, structural members are designed in a such a way that they remain in elastic condition. They remain in elastic condition under the action of working load or external load. Generally, structural members are handled in the elastic range. That is, structural members are designed in such a way that they remain in an elastic condition under the action of working loads. Why they are designed in such a way that? Because when a structural member goes to a plastic stage or a plastic range of a material, it will get a permanent deformation. It will get permanent deformation in the material, and which is not suitable for safe working condition of structure. So this is about the materials. So now we will see the concept of stress and strain. For that, we will consider an example of an steel rod which is fixed at one end and other end is subjected to an external load. Other end is subjected to an external load P. External load. So the length of the rod is capital L and the cross-sectional area is equal to A. So for that, we will consider the steel rod. We'll consider the steel rod of length L and cross-sectional area A, which is fixed at one end and subjected to an external load of a P at the other end. So what is the effect of this external load on the behavior of the material? So material will get deformed. So this deformation due to the external load, let us assume it as a delta L. But the ability of material to resist this deformation. Material has the ability to resist this deformation. So how the material is going to resist this deformation? So material will produce an internal resisting force which is acting in the vertically upward direction, that is exactly opposite to the external load, and this internal resisting force is going to resist the effect of external loading. So now we will see the equilibrium. So when this external load is greater than the internal resisting force, material will continue to elongate. So when this elongation of the material is going to stop, when this internal resisting force becomes equal to the external load. So the equilibrium condition is, is external load is equal to the internal resisting force. So at this instant, when P is equal to R, we can define, at this instant we can define the terms stress and strain. So first point, what is the definition of stress? So stress, so stress is defined as internal resisting force induced in a body per unit cross section of the per unit cross sectional area of the material. So stress is internal resisting force induced in a body per unit cross sectional area of the material. So stress is denoted by a symbol sigma. So this is the symbol by which stress is denoted. So what is stress? Internal resisting force per unit cross sectional area. But in the as per the equilibrium condition, the internal resisting force is equal to P. So stress is equal to P by A, and we are knowing the value of the external load. So this expression of stress, that is P by A, is useful for the mathematical calculations. P by A. So what is, now we'll see the unit of stress. So what is the unit of load? It is Newton. What is the unit of area? It is meter square. Newton per meter square or Newton per mm square. So 1 Newton per, as we know, 1 Newton per mm square is equal to 1 Pascal. So this unit is small unit. So the generally preferred unit is 1 mega Newton per meter square is equal to 1 megapascal. 1 mega Newton per meter square is equal to 1 megapascal, or 1 mega means 10 raised to 6 Newton per 10 raised to 6 into mm square is equal to 1 megapascal. So 10 raised to 10 raised to 6 will get cancelled, and we will get 1 Newton per mm square is equal to 1 megapascal. This is generally preferred unit for the stress. This is SI unit, and CGS unit is dyne per centimeter square. CGS unit is dyne per centimeter square, and SI unit is 1 Newton per mm square or 1 megapascal. So how we have done this? Meter, 1 meter is equal to 1000 mm. So 1 meter square is equal to 10 raised to 6 mm square. So this is the preferred units of the stress. So now we will see the definition of strain. So what is strain? Strain is defined as change in dimension per unit original dimension. Change in dimension per unit original dimension. So strain is denoted by symbol epsilon. Change in dimension, that is initial length minus final length, that is L plus delta L, divided by original length is L. So delta L by L is the formula for strain. Delta L by L is the strain. So now we'll see the unit of strain. So delta L is in meter and L is also in meter. So meter get cancelled. Strain is an unitless quantity. Strain is unitless quantity. So in this lecture we have covered the definition of strength, classification of material, and concept of stress and strains. So this is it for this lecture. These points we will see in the next lecture. To get updates regarding our next lecture, please subscribe our channel and stay tuned. Thank you very much.